a lot for the nice introduction, and thanks a lot for having me in a Zoom call. So that's really great. So I will talk about XR or extended reality for sports, because this is one of our main research areas here in Otago at the moment. I'm at the Visual Computing Otago research group, and I'm basically really interested in this kind of area. I hope is the audio okay for you guys?
Yeah.
Awesome. Okay, great. So just let's get started. So basically, I think most of you know there's a lot of technical advancement with regards to sports, watching sports, for instance, from at home, from a television. So, for instance, if you look into what's happening with cricket and cricket ball tracking, there's a lot of technology which is going on, which makes the experience for spectators at home very exciting and very interesting. Similarly, we see this also for other sports. So, for instance, for rugby, there was some kind of really interesting visualization in the Rugby World Cup last year, and just this kind of additional information that we can basically access if we watch sports at home makes it often very challenging for people that are going into a stadium. So because if we look into what's happening if we're now sitting in a stadium, we get this kind of really awesome view of the action, and we get the fan experience and being there with other people. But the problem is a bit, we often miss out in regards to additional information. So basically there's not even a spectator, like a commentator. So it's often quite hard to understand what are the actions on the field. So our idea here was to explore actually what can we achieve with using augmented reality, in particular mobile augmented reality. So this is one of the topics that we are exploring here in one of our main research projects. This is basically a collaboration with a couple of colleagues here in Otago. So we have Chris Button from the Physical Education Department, and Stephen Mills, who's at the Computer Science Department, and Tobias Langlotz and Holger Regenbrecht from the Information Science Department here in Otago. And then we also work together with Jonathan Ventura, who's at the Cal Poly in California. So the idea here was to really now have a look into what can we achieve with regards to using augmented reality to bring a similar experience to spectators that are on site. And since everyone has their mobile phones with them, the first choice for us here was to look into what can we achieve with mobile phones. So basically the device that everyone had in their pockets. And in addition, we were also interested in looking a bit more into the future. So what can we, for instance, achieve when we're using head-worn displays such as in HoloLens? So with regards to this project, we basically had to tackle a lot of different challenges, because as you can imagine, there are problems with regards to accessing content, but then also how to display this kind of content, how to bring everything within one common framework, and then also aspects of the user experience. So what we did initially when we started the project, we were looking into what kind of content sources can we actually access that are often only available for broadcast, and also what kind of additional information do we need with regards to a 3D model of the sports event side, and also additional information like, for instance, real-time player tracking. So we started with setting up a bit of a content source compilation here that we basically then use for accessing data during our test sessions. So we combined 3D and 2D models, for instance, also line markings and with real-time player tracking, but also we had the chance to access sports databases from our partners, Opta, that provide us additional scoring information and additional information about matches. We then put all this kind of information into one common framework, because as you can imagine, all these kind of different content sources are coming with their own coordinate systems, they're coming with their own specifications. So one of the first main challenges here was now to bring all this kind of content into one system, and we call this the on-site AR spectator content aggregator. So it's basically really this kind of system where we now bring everything into one framework, and this then allows us to basically distribute this kind of content on-site for the on-site spectator. In addition, we need to figure, in terms of now displaying this kind of content, we need to figure out where is a spectator located within a stadium. And this is basically one of the major challenges with our project, because if we look into what's happening with sports broadcasting, there's a lot of very expensive technology involved with regards to figuring out where a camera is located. Often you have basically track cameras with sensors integrated, and you would get like a lot of high accuracy information about where the camera is looking at. In contrast, now, if we're talking about on-site spectators, we have the problem that we don't really know where they are located, which side of the field they are basically entering the stadium or the event site. And also the behavior of mobile users or spectators is quite different to what we usually would expect from, for instance, from normal augmented reality users. So what we had to now tackle within the project and we still currently work on are those kind of two main challenges here, which is the localization challenge and also the tracking challenge. So the localization challenge is really this kind of aspect that at first we now need to figure out where the spectator is located once they're entering the stadium. Once we know this, there's basically a bit of a restricted area where they are now experiencing the AR visualizations, but we first need to figure out where they actually are located. And in our project, we explored here different possibilities, and one of the first ideas that we had initially was to just make use of the fiducials or like all these kind of advertisements that we have already available in a stadium environment. And there's quite a lot of information that we could actually easily access and also measure out. So we initially we tried to use this kind of information, but one of the things that we figured out when we evaluated it a bit more in detail was that often the views that we get from, for instance, mobile spectators from these kind of fiducials is not very suitable for a really good AR experience. So you can achieve a quick localization from these advertisements, but it's often requiring the people to be in a really good location, really get like a really good view on those kind of fiducials or the advertisements. So because of this, and also because one of the other challenges that we experienced was that often these kind of advertisements, they're changing, they're maybe not in the right position, and often they're not available at all. So for instance, a lot of them are just getting packed onto the field during an actual match, and you could not really use them, for instance, for a lot of testing outside any matches. So what we then investigated was what can we actually achieve if we now do a model-based localization. So what is possible if we capture a 3D model of our event site and then use this for registration or localization process. And in order to evaluate this a bit more, we basically set up a bit of a interesting system where we had a couple of mobile phones that were attached to a rig and additional sensor. This basically gave us the chance to really get like a really good 3D reconstruction, but also mobile phone footage for testing and doing a proper evaluation of these kind of techniques. And what we did with this data was then to also capture or calculate a 3D model of our event site. So this is the Foresight Bar Stadium here in Dunedin. And what you see here with these kind of red spots that you hopefully see in the stadium outline, those are all these kind of different locations that we basically went to with a camera and then shot different photographs from each position. And this then allowed us to create this kind of very accurate 3D model. And we then use this for exploring different types of model-based localization and with regards to the suitability for on-site spectator localization. And a couple of things that we explored, but one very promising approach is basically based on a convolutional network where we use the structure for motion model basically in combination with the 6 poses that we computed initially from our structure for motion model, and then train the system and use the sense for basically figuring out from which position the spectator is looking onto the field. And this resulted in several very promising directions. One of the main challenges that we still have to tackle here is that this works very well if we have an empty stadium, but as soon as you have then a lot of people within the stadium, it's basically losing a bit with regards to its accuracy. But there are certainly very interesting or very promising directions here. And then once we have figured out where the user is looking at, so once we know exactly where they see it in a stadium, we can then move into tracking. So this means that we basically want to track along where the user is looking at once they are moving with their phones around. And one of the challenges here is that we can't really use traditional SLAM, because the problem is that the behavior of users in a stadium environment is quite different to what we would experience or would expect from traditional SLAM users. So where you basically have this kind of initial baseline. Basically, you really have this kind of swipe where you want to get a bit of a baseline between the camera views to get a really good starting initialization, and then basically track on from there. And this is certainly not possible if you have a spectator that is just seated in a position and they're basically just moving their phones around on a restricted area. So what we then did was we were looking into the challenges here and explored this a bit further, since there are also other application areas where such a behavior, such a movement pattern is very common. So it's not only for stadiums, but also you can imagine if people are, for instance, browsing in a sightseeing scenario, often people, they just move from one position to the next, and then they just start to move their phones around and basically just try to access information, which is, again, not very suitable for these kind of traditional SLAM approaches where you really want to have this kind of wide baseline to get like a really good initialization. So in this image, you see basically one of these kind of movement patterns of our user in red. And as you can see here, it's really more this kind of restricted area, and there's not so much translation going on. So we investigated this then within our approach, where we actually made use of this movement pattern. So we basically just restricted the movement within our SLAM approach to say that all the movements, all the tracking movements are only happening on a sphere-like structure. And this basically provides us with potential also for saving computational power, because we have like a restricted movement. This means there are only there are less components to take into account, and we implemented this kind of spherical SLAM tracking. This was then based on a spherical structure for motion approach, and allowed us to basically perform much better compared to traditional SLAM approaches such as orb SLAM. So once we had then the our tracking and our localization solved, and I'm saying solved, it's not really solved, but we have basically some approaches that are working good enough to explore visualization and also user experiences a bit more in detail. We're then looking into our mobile client and how to basically present content on site. And again, here, one of the challenges is that in contrast to TV broadcast, where you have like a really big screen and you can put so much content into the visualization, with having mobile phones or also head-worn displays, you often work with a reduced screen area, and this makes stuff a bit more challenging. And we basically then investigated different approaches. How can we basically make use of the empty areas, or also canvas areas that we identified within our stadium environment? So we really tried to make use of empty spaces and also suitable areas that are not that exciting for the spectator, such as the opposite spectator stands, but also integrating, for instance, diagrams and information visualization directly into the field of action to highlight certain actions. We also then looked into how can we address latency. So this is basically like a very big challenge in this project, because a lot of information is basically getting captured, and then once you want to display this on the mobile AR system, the problem is the action already happened, and the question is a bit, how can you deal with this, and how can you basically do replays in an augmented reality setting, which is still a bit underexplored. And we looked here into an approach which is called Indirect AR, and this means that instead of seeing basically the live video stream in our mobile AR setup, we would basically just display or replace our live camera view with a panoramic image, and then integrate the content in addition to basically replay these kind of actions that already happened, so to avoid that there's a temporal inconsistency between what the spectator is seeing on site. We then also had a look into the user experience. So what are basically the implications of using such a system on site? So one of the first prototypes we developed here was to just explore this a bit more in a lab environment. So for this purpose, we basically just implemented a very minified version of our stadium and tested a couple of those kind of visualization techniques and interaction techniques in a lab environment, and basically got some kind of first promising feedback from these kind of users in a lab environment. But then also, recently we ran a bit of a more sophisticated field study, where we looked into what does it actually mean now for people that are on site, how would they use such a system, and how would they basically relate to the action on the field. And also we were very much interested here in getting feedback about what is the difference, for instance, between watching a game at home or on television, what kind of features or visualization techniques, for instance, from the TV broadcast would be interesting for people on site, but also what kind of potential have these kind of AI visualizations where you integrate all the content directly onto the field of action and get this kind of spatial relationship presented. So this is an ongoing research project, and there's still a lot of challenges, as I was saying before. So again, latency is certainly one of the main issues that we have to deal with. Then the registration, so I think we made some really good progress there, but there's still more work to do. And also we still need to evaluate the usability more in detail, and basically run more on-site studies. So thank you very much for your attention. And again, thank you very much for having me in Zoom. And I will enjoy later for the question and answer session.